Model-based clustering in Navure. Model-based clustering is a probabilistic approach that assumes data points are a mixture of Gaussian distributions. The algorithm aims to find the best-fitting mixture model by estimating parameters such as means, covariances, and mixing proportions. We will illustrate the application of model-based clustering to a data named satellite NC, which is located in the test data repository. It contains the reads in 4 bands of 8,572 pixels of a satellite image. Once the data file is open, click the Multivariate tab and click the mClustering button. Select all variables and drag and drop them into the traits panel. The algorithm allows for grouping factors. In this example, we don't have a grouping factor, but if we did, all observations that belong to the same class defined by the grouping factors would be summarized before entering the analysis. In this scenario, the instances that are grouped are the classes defined by the grouping factors. Now click the blue play arrow. A dialog appears. It has 2 panels. The left one contains a list of possible ways to summarize the observations of each class defined by the grouping factors. By default, the summary is the mean. These options only apply if a grouping factor was specified. In the panel on the right, there are several options. If number of clusters automatically is checked, the algorithm decides on the best number of clusters. Generate sequence only applies if the previous option is unchecked and the number of clusters is greater than 2. In this case, the algorithm will generate classifications for 2, 3, and so on until the specified number of clusters is reached. If you don't know how many clusters to create, leave the first option checked. This is what we will do in this example. Now let's press the OK button. The algorithm is CPU intensive. In this example, it will take about 17 seconds to converge on the current machine. Unlike other clustering algorithms, the model-based algorithm can give you an explicit solution for the number of clusters. A word of caution, though. There is no one clustering algorithm that is always the best. So, if you are not completely satisfied with the solution you get from one of them, look at other algorithms to make a final decision. The results suggest that there are 4 groups in the data set. Returning to the data table, you'll notice the addition of 2 new columns labeled K4 and UN_K4. The first column represents the cluster assignment, while the second column represents a classification uncertainty ranging from 0 to 1. A value closer to 0 indicates a higher degree of confidence in the cluster assignment for a given data point. If we run a summary statistic for the uncertainty, using K4 as a grouping factor, we see that the mean of the uncertainty is 0 for clusters 3 and 4, and very low for clusters 1 and 2, indicating a good classification result. Furthermore, if we reduce the dimensionality of our dataset to the first 2 principal components and plot a scatter plot with these new coordinates, and use K4 as the partition criterion to see the data point belonging to each cluster with different colors, we can visualize what the clustering algorithm found. To do this chart, go to the Multivariate tab, click the PCA button, select C1 to C4 and then drag and drop them into Traits panel. Then press the blue play arrow and uncheck Generate BI plot. Return to the table and 2 new columns, named PC1 and PC2, were added. Now plot a scatter plot using these 2 variables. Press Scatter button in the Graphics tab, move PC1 into the X-axis, move PC2 into the Y-axis, and use K4 as a partition criterion. Then press the blue play button. It is very clear that the clustering algorithm succeeded in finding 4 clusters.